A buck regulator is a DC-DC converter which converts a higher voltage potential to a lower voltage potential. It uses a switching element to ensure a steady DC output of required voltage. I am Reshma, and today we will discuss the operation of a buck regulator. In this topic today, we will learn more on switch average current, switch RMS current, switch peak current of a buck regulator in continuous conduction mode. When the switch is turned off, there is no current in the switch. However, when the switch is turned on, the current flowing in the inductor is the same current that is flowing in the switch. This is the rising current of the inductor. Hence, the switch current is the rising current of the inductor. From our previous videos, we saw that rising current of the inductor is I2 minus I1 into T divided by T1 plus I1. As switch current is the rising current of the inductor, this value is also equal to the switch current. We saw that switch current is present only when the switch is turned on, and when it is turned off, the current is equal to 0 amps. Then the switch current is given as I switch 1 of T for 0 to T1 time and 0 for T1 to T time. Now that we have established the switch current equation, let us now derive the average current of the switch. Average switch current is the integration of switch current over one cycle. Let us now split the on time and off times. It can be simplified as shown here. While deriving the average current equation, we saw that integration of rising current of the inductor is given as dt into I1 plus I2 divided by 2. Hence, we can substitute this value in the average switch current equation. This is shown in this equation here. We can now substitute the integration of rising current of the inductor in average switch current equation. We now get this equation here. In this equation, T and T gets cancelled and the average switch current is given as D into I1 plus I2 divided by 2. We can see that switch average current is dependent on the duty cycle and the ripple current. From our previous equations, we know that I1 and I2 can be represented in terms of average inductor current and ripple current. We know the average switch current equation that we derived in the last slide. Let us now substitute the value of I1 and I2 in average switch current equation. We can cancel out the common terms. On simplifying, we get switch average current is equal to D into inductor average current. Let us now look at the RMS switch current equation. RMS current is given as square root of 1 by T into integral 0 to T I switch square of T into dt. Now, we saw that switch current is present only when switch is on, and when it is off, the current is 0 amps. Square of switch current can be represented like this as shown. Let us now split the terms with on and off terms. Switch current during off time is 0 amps. Hence, we can consider the current only during the on time. In our previous videos, we saw that the rising current of the inductor is equal to I2 minus I1 by T1 into T plus I1. As the switch current is equal to the inductor rising current during on time, this is also equal to the switch current. We also have previously seen that squaring of the rising current of the inductor and integrating results in 1 by 3 into dt into I2 square plus I1 square plus I1 I2. We can now substitute this equation in the above equation. After substitution, we get dt into I2 square plus I1 square plus I1 I2 by 3. We can now substitute the square of integration of rising current of the inductor in the RMS switch current equation. We now get this equation. Here, t and t gets cancelled and we get the equation as shown here. Hence, we can now write the RMS current equation as square root of d into I2 square plus I1 square plus I1 I2 divided by 3. From our previous equations, we know that I1 and I2 can be represented in terms of average inductor current and ripple current. We know the RMS switch current equation that we derived in the last slide. Let us now substitute the value of I1 and I2 in the RMS switch current equation. We get the equation as shown below. Let us now simplify the equation. We can use a plus b whole square, a minus b whole square and a plus b into a minus b formulas for simplification. Here, few terms gets cancelled out. On simplifying, we get this value. Let us now take 1 by 3 value inside the bracket to get this equation. Thus, RMS switch current value can be written in terms of average inductor current and ripple current as shown here. Let us now look at the switch peak current equation. We can see here that I2 is the peak current. This is nothing but the inductor peak current. Thus, switch peak current can be written as inductor peak current, which is equal to inductor average current plus delta I by 2. To conclude, we can write switch average current is equal to d into I1 plus I2 by 2. Switch average current is also equal to d into inductor average current. Switch RMS current is equal to square root of d into I2 square plus I1 square plus I1 I2 by 3. Switch RMS current is also equal to square root of d into inductor average current square plus delta I square by 12. Switch peak current is equal to inductor average current plus delta I by 2. In this video, we saw switch current equations. We will learn more in our subsequent videos. Until then, let's keep exploring and learning. Thank you.